All right, what questions do you have off of this homework? And you had to do all 6 of these?
Number 2.
Okay. What?
How come we do 2, like 2
Square root of 2?
instead of just the square?
Instead of just the square root of what?
Like,
Shut up.
Okay. Up over the nose. Same deal, Caroline. You need to get another mask. What were you asking though, Cheyenne?
so when you do the square root of 1, it'll say 2 square root of 2.
Did you look at the directions on the sheet? Guys, this is frustrating. We act like we have no clue what to do. I know that I have not talked about simplifying radicals at all in class, but you see all of this information above it? That might be giving you instructions on 2.5 about how to do radicals. Alright? And they give a couple of examples here with the square root of 20 and the square root of something else. So, when we talk about a square root, what's the square root of 16? 4. Why is 4 the square root of 16? Because 4 times 4 is 16, right? The square root is trying to find, well, another way to think about it is 4 squared, right? The square root is undoing that square. It's finding out what was multiplied by itself to get 16. Now, when I look at the square root of 40, is there any whole number that I could multiply by itself to get 40? No. Are there any factors, though, of 40 that I could multiply by itself? Yeah. What factors? How could I rewrite 40? What times what?
10 times 4.
10 times 4 makes sense.
2 times 20.
Well, let's think about that. 2 times 20. Can I take the square root of 2?
Yep.
Do you know what the square root of 2 is?
1.
No. Half of 2 is 1. But if you're saying that the square root of 2 is 1, that means that 1 squared is equal to 2. Is that true? Remember, the square root is the thing that is multiplied by itself to get a number. Is 1 times 1 equal to 2?
Nope.
So is the square root of 2 1?
Nope. It's 2.
Can you easily take the square root of 20? No? Okay, but let's look at 10 and 4. Can you take the square root of 10 easily?
No.
Yeah, notice how that 10 is still underneath my square root? But do we know what the square root of 4 is?
2.
2. So I literally just took the square root of 4, and it's 2. It's now outside the radical because I took the square root of 4. That's all I did. Does that make sense, Cheyenne? Okay. If you read through those instructions, right, it breaks it down to this idea of, hey, I need to find a factor that I can take the square root of. Now, this was just a check to see if we had questions, but you should have tried that on your own once before you got to this, or tried it on your own before we went over these. So when I look at the square root of 50, is there anything that I can take the square root of? Any number that I know multiplied by itself would give me a factor of 50? 2 times 25? Which of those can I easily take the square root of?
10 times 5. I'm talking about equal up to 50.
I assume that's what you were trying to get to?
Mm-hmm.
But can you take the square root of 5?
Nope.
Can you take the square root of 10? Nope, not even get an integer at least. I mean, you can. Let me clarify. You can take the square root of 5. You can take the square root of 10. You're just going to get a decimal because they're not perfect squares. But you were saying earlier, what's the square root of 25? It's what? 5. So the square root of 25 is 5. Notice it is no longer underneath the radical because I took the square root of it. Can I easily take the square root of 2 and get a whole number?
Nope.
So that 2 stays underneath the radical. Right? So what number multiplied by itself twice gave me 25? The answer is 5. It's outside the radical. What's a little bit different though about number 3?
It's cube.
It's not an exponent, say,
Cube.
say it again.
Okay, so
Cube root.
A cube root. Remember, a square root is looking for something that is multiplied by itself twice. What's a cube root looking for?
3.
Something multiplied by itself 3 times. Now, does anything multiplied by itself 3 times get me to 16?
8.
8 times what?
30.
8 times 3 is 24.
It is?
Yes.
6 times 3 is
18.
shoot, man.
Take them.
Yeah, factors, man, they're getting us right now.
I was so.
What's 4 times 4 is 8.
Okay, so cube root of 4 times 4. However,
4 times 4 is 16.
if I think about a cube root, can I multiply anything by itself 3 times and easily get a 4?
No.
No. So we need to think of other factors.
3 times 2.
2 times 2.
Donovan, what were you saying?
I think so
3 times 2?
3 times 3. No, I
That's
think so.
9.
Yeah, that's 9. Let's do this. This is another approach to it, because this might help y'all a little bit. Like square root of 40. Did y'all ever do factor trees
Yes, Miss Corey.
and prime factorization? So what are factors of 40?
10.
4 and 10.
4 and 10. Are there any other factors for 10? 5 and 2. Any other factors of 4?
2.
Okay. So if you want to think about it this way, you could think that's 2 times 2 times 2 times 5. You see how I have 2 2's right there? So can I take the square root of those things because they're being multiplied by itself? So what would be the square root of that? 2. And so it would be a 2 times 5 is, that helps, that's another way to approach it. Right, that's again the idea of what multiplied by itself gives me 4. The answer is 2. Similarly, if I look at 50, what factors are there for 50? 5 and 10. Any other factors for 5?
No.
No, there's 5 and 1, but that doesn't give me new factors. What about 10? So notice that square root of 5 times 2. There's that 25. But because I have 2 5's being multiplied, what's the square root of 5 times 5?
2. I mean.
Say again.
5.
5. Literally, what is being multiplied by itself?
Across your face.
5.
Oh!
If you still not seen an answer one more time.
Okay? I'm so scared to know what just happened.
I'm not.
He copies everything that I say.
Well, thankfully he doesn't copy how you wear the mask. Keep it up over the nose.
Yes, he does. It's not over it right now.
I can't tell.
Bigger ones.
Oh my gosh. That wasn't obvious at all.
I know.
But notice, Donovan, the question is what is being multiplied by itself to get that number? Well, literally 5 is being multiplied by itself, right? When I look at 16, if you need to approach it this way, what are factors of 16? 4 and 4? What other factors are there?
8 and 2. Wait, what's 8 times 6?
2 and 2. And
Oh, I thought we
you can do it that way, but so is there anything being multiplied by itself 3 times?
No.
No. Only 2 times. I mean, yeah.
There's 3 2's right there, right?
Yeah.
So what is the cube root of those 3 2's being multiplied?
2.
2.
Now this 2 is still underneath the radical because I cannot take the cube root of it. So you can break it down into prime factors and look at it that way. What I would do is, notice we broke it down here into a perfect square and a non-perfect square. A perfect square and a non-perfect square. So when I'm looking at this cube root, I'm looking for a perfect cube and a non-perfect cube. What is 2 times 2 times 2?
8.
8. That is a perfect cube. What I would have looked for is something that is being multiplied by itself 3 times. And 8 does that. And what is the cube root of 8?
2.
And so the 2 comes out, and then this 2 stays underneath. We've done radicals in Algebra 1, right?
It's been a while.
It's been a while, but yes.
Yes.
Sure.
Okay. We need a refresh on this apparently, so I'm glad we're doing this. But what are your questions about numbers 1 through 3? We'll have some more practice tonight with 4 through 6 before it's an accuracy grade. No questions? Okay. Any questions about 10, 11, or 13 for these arithmetic and geometric means? 11? What about 11 gave you trouble? Say again.
Miss, can I use a staple?
Hmm?
Can I use a staple?
This negative 3? Did you get all the other numbers? So what'd you get for A? And then for B you got, so how'd you get that 11 and that 4? Okay, so we need to know how we're doing this. McKay, Caroline, keep your heads up, guys. We have struggled too much on arithmetic means and geometric means for anyone to not be paying attention right now. Can anyone explain to me? Well, first off, let's start with something simple then if we're struggling a little with number 11. How could we have found this 8 right here? You can guess and check, but we need to be more efficient than guessing and checking. Guessing and checking worked when we first learned something, but then we're supposed to learn strategies to help us speed up the process. For instance, as soon as I see that this is arithmetic, what should that tell me? What should that tell you? It's adding. Meaning it's an additive rate of change. Now, before you find this value, do you know what that rate of change is?
No.
No, but you know you're adding, right? And what do we call an additive rate of change? So I'm adding the common difference here and here. Could I potentially write an equation from this to find that common difference? What equation would I write? I see a lot of people like looking or maybe trying to sleep, but very few of us are actually taking notes, maybe to be able to get this correct in the future. Say that one more time.
F of n equals 5 plus d squared.
Okay, so if we square something, that indicates we're repeatedly multiplying. Are we repeatedly multiplying here?
Nope.
Nope. Now,
Plus 11.
I would agree that we could start with 5. That's where we're starting, right? But I'm adding. How would I indicate that I'm adding d twice?
Divide.
Multiplication.
So times 2d.
Well,
d2.
plus
Yeah,
2d. We're starting at 5, then we're adding our common difference twice. After we add our common difference twice, what do we get to? 11. Notice I didn't ask for a function, I asked for an equation. I don't need f of n. I know what I'm ending at. I'm ending at 11. Now I can solve it. So I'm adding what each time?
3.
So 5 plus 3 is 8, 8 plus 3 is 11. Could we use a similar strategy on number 11?
Yes.
Mona, how do you think we would adapt that strategy for number 11?
What is the, on the, 2 and 6?
Here,
Yeah, on there.
dividing by 2, and then d is equal to 3. Do we understand why I divided by 2 there? Yes, sir.
You're multiplying the 2D's.
So I'm multiplying 2 times d, so I undid that with division, right? Also on top of that, what is 2 divided by 2? 1, right? So I'm creating that identity 1. Alright, so how could we adapt that strategy from number 10 to do number 11?
The same thing.
Okay, what is the same thing though? We got to adjust it a little bit.
18 plus 4D.
Sean, where is McKay getting 4D from?
Plus, moving 4 spots,
Because he's what?
moving 4 spots,
Moving 4 spots?
with 4 common differences.
Okay. Now what do we do with the common difference though? This is an important detail. He's adding it. Notice you can literally show this, right? I'm adding the common difference. I'm adding the common difference. I'm adding the common difference. And then finally I'm adding the common difference. I'm adding 4 common differences. At the end of all that, what do I get?
Equals -10.
Money, do you agree with that equation? You don't need a calculator.
I was trying to figure out something.
Okay. But do you agree with this equation? Yeah? Donovan?
Yeah,
Okay, why do you think this equation is correct?
if you start with 18, and you add a 4 common difference, you get negative 10.
Okay, you're starting at 18, you're adding 4 common differences to get negative 10. There we go. How can I use this now to figure out the answer to this question? Or the answers. You could plug it in, but what is this? This is an,
Equation.
what can you do with an equation? Solve it, meaning finding what makes the equation. How would we solve this?
-18.
Say again.
You can just say
No, you didn't.
-18.
Subtract 18.
Yep.
What is 18 minus 18?
0.
0. So that makes a lot of sense, right? I want to know what common difference is. 18 minus 18 is 0. What's 0 plus 4D?
4D.
Okay. What's negative 10 minus 18?
Negative 28.
Mm-hmm. What would be my last step?
Divide by 5.
Okay. What is 4 divided by 4?
D1.
Well, 4 divided by 4 is 1. 1 times D is. So my common difference is negative 7, meaning I'm repeatedly adding what?
Negative 7.
Or just subtracting 7. 18 minus 7, that's 11, right, Mona? 11 minus 7 is 4. 4 minus 7 is negative 3. That's why it was negative 3. And notice negative 3 minus 7 is negative 10. If you can find your rate of change, you can answer these questions. Now I need to pause for a second because I need to say this. I'm a little aggravated right now. Do you know how long we've been doing arithmetic means and geometric means?
Since school started.
Not since school started. That's a little extra. But this is literally the first lesson that we did within this unit. This is our 5th or 6th week on this lesson, or on this unit. See how there might be a problem with that? You want to know the biggest reason why a lot of us are still struggling to do this? Because we don't do the homework and then we wait for Mr. Kinney to do it for us when we come to class. So 1, you're getting zeros on the homework. 2, you're not getting the practice in that you need to be successful. It's not rocket science, guys. You put in the work, you earn the grades you want. You put in the work and you learn. Because ultimately, hard work pays off. That seems to be a thing that some of us are missing right now, though. So let me restate this so that you get it, hopefully at some point. Hard work pays off. You got to put in the effort. If you want to earn a good, strong grade, then you need to actually learn the content, which means you need to put in the time for the homework. I don't assign homework to be a jerk and to make your life miserable or anything like that. I do it because I know you need the practice, because everyone needs the practice. I needed the practice when I was in high school, I needed the practice when I was in college, and I know that if you don't get the practice, you're never going to learn it as well as you need to actually have use for it in your life. Which I know some of you are like, but Mr. Kennedy, math is stupid, there's no way we can use it in everyday life. And I cannot tell you that is more false. Math is a language. It's a language of noticing patterns and making sense out of those patterns to make our life easier. Maybe the way you've learned math in the past is not directly applicable to your life. But math is. I need you to do the work. And if any of you have any aspirations of going to college, then you have to learn how to do homework. 2/3 of everything you learn in college is done outside the classroom. Meaning homework, meaning projects, meaning studying, all that stuff. At least 2/3. You gotta learn how to do homework, guys. And I gotta learn how to hold on to a marker. Okay. Number 13. I know that it is a little bit simpler, but I still want to talk about this one because it'll impact your ability to do tonight's homework and understand geometric means. How can we adapt what we did with the arithmetic means to help us in number 13 with geometric means? How can we take what we did with arithmetic means and adapt it to help us with geometric means in number 13? Okay, so what are we going to multiply by?
3 times 2D.
So we use D because it's called a common difference.
Rate of change. Isn't there a rate of change?
Mm-hmm.
It is a rate of change, but they're both rates of change. What's the multiplicative rate of change called? Common ratio. So multiply by R. Hello? No, ma'am. I have not seen him today. Gotcha. Yes, ma'am. Okay. Okay. So notice we're multiplying by R. I heard some of us say times 2R. If we're repeatedly multiplying by R, though, do we want to do 2R?
Or squared.
We need to notice that the mathematical or the operations and what we're repeatedly doing is defining what's happening. Now we are going to multiply by R squared. But what are we multiplying by R squared? 3. And after I start with 3 and I multiply by R squared, what am I getting? Now you can solve it, you can guess and check with that R, but we want to notice whatever we're multiplying by twice gets us 12.
So the variable is just how many times you find that ratio?
How many times you're multiplying by the common ratio when it's geometric, right? When it's arithmetic, it's how many times you are adding the common difference. So 3 times 2 is 6. 6 times 2 is 12. We ready to move forward? Which of these questions do we need to talk about with 19 and 20?
Cool.
Any of them? Like what would you have gotten there?
Yeah,
It's a good question.
well, I've got 0.049, but I didn't leave it as a fraction.
Point what again?
0.049.
It's not that. You would have gotten 0.02491. That's a decimal. Now, I will say if you had shown your work for this, you might more easily recognize how to do it. Notice, what is this -4 going to take the place of? X. So g of -4 is equal to 3 to the -4 times 2. Now this actually ties directly into what we've been doing. Put the calculator down. What does this negative exponent tell you to do? To divide. 2 divided by 3 raised to the 4th, because I'm dividing by 4 3s. Right? Now some may know 3 to the 4th off the top of their head. I don't imagine most of us do. But that's 3 to the 4th, right? What's 3 times 3? What's 3 times 3? 9 times 9 is?
81.
No calculators needed. But it requires paying attention to what the numbers are and thinking through. Which I know we're not used to dealing with exponents like that, but that's how we could approach it. Does that make sense, McKay? Any other questions we need to look at? Okay. How long do y'all think it should take us to go over homework each day? I mean, I know ideally in your world, 0 minutes because we didn't have homework, but how long do y'all think we should take going over homework each day? Linnea, I see you shaking your head. Why?
We're just thinking like 5 minutes.
5 minutes, right? I'd agree with that. 5 to 10, maybe. Do y'all know how long it took us today? 30 minutes. Why do you think it took us so long? Because we didn't do it. This is a vicious cycle. I need you to understand this. When you don't do the homework, it takes us more time to get stuff done in class, which means that it takes us more time to do the homework and go to the homework in class, which means you have less time to do actual learning. And it keeps putting you back into a hole time and time and time again. And we keep doing the same thing over and over and over again. I need you to learn from your mistakes. The number one mistake being, we just don't do the homework. And I get it. Some of us have jobs after school. Some of us have to take care of family after school. I get it. However, I am telling you, it will make a world of difference for your academics and it will make a world of difference for your personal life if you can learn to make the time to do the work. I too had a job when I was in high school. I had a family that I had to be a part of in high school. But I also made sure that I did my homework before I started watching the new movie that I just got on Netflix. And just to clarify, yes, I'm old enough that I had to get DVDs. Netflix wasn't streaming when I was in high school. So it was a little bit different. I get it. But I put in the work before I started playing. You've got to put in the work, guys. If you don't put in the work, it's going to bite you in the butt. And I cannot emphasize this enough. I give you homework because I care about you and I care about your future. I give you homework because I want the best for you, but you are choosing to not have the best for yourself when you don't do the things I asked you to do. I need you to start doing the homework. You, your future you, needs you to start doing the homework. Let's look at the objectives for 2.5 when we get back to 2.5, half interested. We just barely got started on it yesterday, but we'll just barely get into it today. So, who read yesterday for objectives? You two, who else? Maybe Gavin? I don't know.
I think it's Alan.
Oh, Alan. Cheyenne, can you read the first objective for us today?
I can explain a need for negative and rational exponents in the real world.
So we really need to get to doing some of this. Remember, math is not designed to make your head hurt or to make your life miserable. It's actually designed to help you in the real world. It has its uses, its applications, and that's what we want to focus on. Linnea, can you read the second objective for us?
I can connect the usefulness of a recursive definition of a function to discrete relationships.
Recursive definitions go hand in hand with discrete relationships. That's huge, and we want to see that today. Mona, can you read our last objective for us?
I can connect the need for explicit formulas in a function to continuous relationship.
So we are seeing very clearly that recursive is going with discrete, whereas explicit is going to go with continuous. Those are just words on a page right now, or technically on a screen. We want to see why that is true and how that applies to us today. So we started looking at Carlos and Clarita, the Martinez twins. They've run a summer business every year for the past 5 years. For those of us who were here yesterday, we looked at the fact that they've earned a small profit and their dad made them put it into the bank. And we got into a discussion, I think, about if you could actually earn money through interest at a bank. And we kind of talked about the fact that, well, yes, but definitely not the 5% that they're alleging here. It doesn't give you that much at all. And we talked, I think, a little bit, maybe stocks, we got a little distracted. But it's still important to, go into those things a little bit. Okay, so he found the annual bank statement for their money that's been earning 5% interest annually for the past 5 years, and they currently have $382.88, right? That's the very front of that 2.5 that you have in front of you. And so let's recap here, especially because I didn't record it yesterday. Given the facts listed above, how did we explain that the twins could figure out how much the account will be worth 5 years from now when they are 20 years old? What did we end up doing? Did you not take notes yesterday? They didn't divide.
Multiply.
Okay, so we needed to remember, so where did that 1.05 come from? Well, he has all of his money, so how would we represent that? Right, so that's the 100%, and then they're gaining how much? And so they're gaining 5%, meaning that they now have 105%, right? Every year, they had 105% of what they had the previous year. Right? And that 105% became that 1.05. We have done this since last unit, where we talked about these percentages. We want to recognize that if you have all of something, and that's usually your starting point, you're dealing with 100%.
Why do you say plus 59? Oh.
Percent. Sorry. Is that it? Better? Okay. So, the idea in general is that we usually start with all of the thing, all of the money, or all of the price, all of the something, and then you're either adding or subtracting price from it. And so every year, you can do 105%. And Gavin was pretty convinced yesterday, I believe, that it was easier to do this, right? And then you add 5% of that number. But then we kind of convinced him by the end, and hopefully everyone else, it's a little bit easier to just do this. Is that fair to say? That's an easier strategy? Remember, math is not, or is all about finding patterns and making language out of it, or making a language out of it so we can make our lives easier. Remember, we've only studied 2 different types of functions so far. Arithmetic sequences, which are linear, because we have an additive rate of change, and geometric sequences, which are exponential, because we have a multiplicative rate of change. Those are the only 2 things we have studied so far. I'm not going to give you anything else. I'm not going to give you a combination of addition and multiplication. It's either going to be additive or it's going to be multiplicative for now. Okay? We good with that? I'll take silence as a yes. So Carlos calculates the value of the account 1 year at a time. He has just finished calculating the value of the account for the first 4 years. Describe how he can find the next year's balance and record that value in the table. So we said, hey, multiply by 1.05, and we got 480 something?
Yeah, I think it's 480.
Oh, there we go. 488, yeah. Oop, there we go. 488.66. Knew I had it as a part of the slides. So, I want you to notice, Clarita thinks Carlos is silly. This is picking up in number 3. Calculating the value of the account 1 year at a time, and says that he could have written a formula for the nth year and then evaluated his formula when n is equal to 5. I want you to notice that again, this is the idea that we are looking for patterns to help speed the process up. We're looking for a way to say, hey, I see a pattern here, let's use it and apply it. So first off, I want us to really clearly understand this. Carlos was calculating each year, right? One at a time. Whereas Clarita is thinking, hey, you should just write a formula and then you can plug something in. What ideas are they using there? They're kind of different, but they're very closely connected. Any ideas? There are 2 different types of equations that we study, not sequences, 2 different types of equations. So linear and exponential are 2 types of functions. They're not types of equations. Say again?
Recursive, explicit.
Recursive and explicit, right? Which one is Carlos using, going year by year by year by year?
Recursive.
Recursive versus explicit. It's one of those 2. Raise your hand if you think it's recursive. 1, 2, 3. Raise your hand if you think it's explicit. Cheyenne. And we got 1, 2, 3, 4 who are just scaredy cats and don't want to answer. Or like Mr. Kinney, this is Lynn, ignore me.
Yep, that's what.
That's also it, I get it. That's what is going through Caroline's head all the time. Unless she can like look into the camera really quickly and then stick out her tongue, she's like, I don't care. Even though I don't know how you managed to do that because you're never supposed to have your mask off.
Does it actually get it in the video?
It did the other day.
Is it recording right now?
Anyways, so the majority of us are thinking recursive. Remember, a recursive relates the current value to the previous. Is he using the previous value to get the current one? So Carlos is using a recursive idea. Specifically, I do want you to notice, f of n is equal to f of n minus 1. What would he write next for his recursive idea?
Times
1.5?
1.5.
Notice how he's repeatedly multiplying the previous number by 1.05 to get the current one? That's a recursive definition. But he only wants the fifth year, so does he really need all of these things in between?
No.
Well, that's why Clarita's saying, hey, you're being silly. Say again? So remember, this is a recursive definition relating the current to the previous. Is Clarita trying to use a recursive definition? She's trying to use an explicit, right? He could have written a formula for the nth year. That's an input. Not the current output and the previous output. That's the input and output. And then evaluated his formula when n equals 5. So write Clarita's formula for the nth year. How could we write this formula?
F of n equals 3 over 2, 188 times 1.5 to the field power. 1.05.
1.05?
Yeah.
Now, let's talk about this and make sure that we understand where this is coming from, or if we even agree with all of this. Mona, where is this 382.88 coming from in Donovan's equation?
From the first one?
Say again?
From the first input?
From the first input? Now, one thing I want to clarify about that. Look again, is that the first input?
Oh, no.
They're starting.
So it is a starting point, but first off, is that an input?
Oh, no.
No, what is it? An output. So we might want to say it's the first output, but is that even the first output? Which output is that?
0.
The 0th output. Notice it's small things like that, but it's important language. Now, Caroline would have been correct to say that's the starting point, but we want to be more explicit with that, more clear with it, saying, hey, f of 0 is equal to 382.88, or the 0th output is 382.88, right? That's our starting point. Technically, you could also say the y-intercept. Y'all okay over there?
I don't know.
I'm gonna split y'all up.
I'm trying to-
Please do.
So 382.88, that is the starting output. We all get with that idea?
Mm-hmm.
Okay, so then why is Donovan multiplying by 1.05, Cheyenne? Okay, let's think about that language. Does anyone know why I might be hesitant to say that's what it's increasing by each time?
Because increasing.
That's
That sounds like adding.
Do y'all agree with that idea
I
that
would
increasing
never, but
implies
I was gonna
addition?
say that.
I mean, increasing, does it imply addition?
Yeah.
Yes.
Technically, it does just mean that it goes up, right? But typically, increasing indicates that we're adding.
Multiplying.
So we might say we're multiplying by 1.05, right? Or it's increasing by a multiplicative, by multiplying by 1.05. But we want to make sure that it's very clear again that it's not just adding.
Does
that make sense? Do you see the difference? Now, I do want to pick on this a little bit. Look at the whole equation. Donovan said f of n equals 382.88 times 1.05 to the fifth. Now, I get why he put to the fifth. However, where's his n showing up?
In this stuff.
N, the input, is that anywhere in your equation, Donovan? Nope.
Would be-
That'd be 1 point.
would be 5. F
Well,
of
it's
5.
supposed to be F5.
Okay, so we could say f of 5,
We can change it.
but let's make it f of n. So let's write f of n, right? F of n equals 382.88 times 1.05
Yeah.
raised to the n. Then, when I say f of 5, I'm plugging that 5 in. Notice it says, write Clarita's formula for the nth year and use it to find the account balance at the end of year 5. So really, we should have done this and then this. Okay.
Just fail. Open my mouth and drop down.
Can someone use a calculator? Actually, technically, we should all have calculators. Each of us pick up our calculator, type in 382.88, multiply it by 1.05 to the fifth. Hey, Caroline, you have a calculator too. Thank you. Mona,
We
this.
don't need it to read out loud. We don't need you to talk out loud.
I don't care.
Hey,
No,
hey,
no.
how about you focus on your calculator? If he needs to read it out loud to help remind himself of what to do, that's fine.
2.88
Just
times.
got on the video.
Times.
Man, you know, I taught high schoolers to get away from this level of immaturity. Apparently I should have like taught college.
Probably.
488.66.
Wait, so you're telling me that Clarita would have gotten the same answer as Carlos?
Yeah.
Tell me, which one would have been taken less work? I know it took us a little bit of work to get to the equation, but what would take less work? Just plugging into that equation or using that recursive definition?
Clarita.
Clarita's? Explicit? So again, so one thing I want you to notice, and we've talked about this in the past, an explicit equation is going to help us get values further into the future quickly. With an explicit equation, you could plug anything in and automatically get the output. Whereas with a recursive, you have to go year by year by year. Are we all good with that? Any questions about that? So, we are supposed to be almost done with this task. Hopefully we'll be able to get there tomorrow. But you'll pick up number 4 within your groups. And, I don't know, we'll see. Yeah, we haven't quite gotten to these. we'll get started with the objectives tomorrow. Here's your homework. Complete any missing assignments. Ready numbers 4 through 6. Set number 12. Numbers 15 through 17. And go numbers 21 through 22. Let me modify this a little bit since we're behind.
Oh, man.
Oh, do that. Here, 1 minute.
Alright, so there's your homework. Numbers 4 through 5, set number 12 and number 15, go number 21. Do not leave until you clean your desk.
Oh, that's not the, yeah, I have that one.
McKay, Caroline.
Wait, did you already spread?
Yep.
Oh, okay.
Okay.